This session definitely is extra special, not only because of our presenters, not only because of our speaker, but because of the date, which is 14th of February, a Valentine Day. So we'll make sure to add all the flavors in today's session relatively. So thank you for spending your time with us, celebrating our day. We are thrilled to have you here. What we promise to have an exciting, interactive, and insightful journey. So, one disclaimer is we have a very exciting trivia at the end, which is very, very worth waiting. So, definitely stay tuned. And let's now jump into our session overview. Or before, let's talk about the today's topic. So, today's topic is data handling in Mule, streaming, pagination, and looping. So we'll break down each topic in detail and we'll explore the real world application. We'll discuss its implementation. We will also talk about the special strategies for our MuleSoft project. And yes, this will be our interactive session. So jump in and share your thoughts, share your questions, and we'll definitely acknowledge all your questions in the middle of the session or in the last of the session. Mm, so, yeah, let me take some time to introduce my fellow mates. So, let me introduce my amazing Kolkata meetup organizing team that made today's session happen. I'm not sure if I have everybody here, but definitely Priya Shaw. So, let me firstly start with myself. Hello, everybody. I'm Jyoti Chaube, working as a senior solution consultant at Kelis Consulting. More description on MuleSoft community sidebar. I'm a MuleSoft mentor, Kolkata meetup leader, MuleSoft community channel moderator, and yes, MuleSoft certified developer as well. So that was all. Priya, over to you.
Yeah, thanks, Jyoti. So, hi everyone. This is Priya Shao, and I'm currently working with LTI Mindtree as a senior specialist. So, it's been over 6 years I'm working into integration space, and I'm a MuleSoft ambassador and meetup leader for Kolkata and Mysore. So, yeah, that's a brief introduction about myself. Yeah, if you are interested joining our meetup group or if you're interested in giving any session, do reach out to us. We are there for you. Yeah, thanks a lot.
Definitely. Other than that, we have Suman Chatterjee. I'm sorry, a senior architect at ProS Software Service, Brajeshwar Roy, a tech architect, tech manager at Exavalue, and then Indranal Paul, who is a technical specialist at IBM. Now, before jumping quickly on the topic, we'll check out the safe harbor statement for the productive session. So, both of the speaker and host are organizing this meetup at individual capacity. We are not representing our organization here. This presentation is strictly for learning purpose. We do not hold any responsibility that same solution will work for your business use case. Also, this presentation is not meant for any promotional activities. Jumping on to our speakers, I'm very excited to introduce our speaker, but I'll not grab this chance. I'll let them introduce themselves. So over to you, Pragati.
Thanks, Jyoti. So, hello everyone. Myself Pragati, working as a solution consultant with Gillis Consulting. So, I hold 2x MuleSoft and 2x Salesforce certifications. And being a certified MuleSoft developer, I hold experience in MuleSoft part or the integrations and in various domains. So, over to you, Sonakshi.
Yeah, thanks, Pragati. So, hello everyone. Myself, Sonakshi Mahajan, and I'm working as a solution consultant at Kalias Consulting. I am a 2x MuleSoft certified and 1x Salesforce certified. And till now, during my work experience, I have worked in various projects belonging to various domains. And I'm really happy and pleased to be a part of this meetup as a speaker.
That's great. Thank you so much, Pragati and Sonakshi. Let me quickly brief about today's topic, and then we'll jump onto the agenda. Like we are having the agenda, we'll jump onto the explanation part. So we firstly have MuleSoft ETL pattern, a brief discussion about this. Then we'll have a challenge statement for why we are using pagination, looping, and how it will benefit our MuleSoft application. Then we'll have the solution designing with pagination and looping, demonstration respectively after the description, MuleSoft streaming, their demo, streaming in DataWeave, and then a demo. And the very excited part, for which I'm also excited, the trivia, though I'll not be participating here because I know the answers. Yeah. So that was all about our agenda. Let's jump on to the details for the session today, and I'll give over the stage to Pragati. Let
Yep.
me stop sharing.
Thanks, Jyoti. So let me quickly pull up my screen.
Yep. And meanwhile, I was just saying that you can ask your question anytime in the chat. Yep.
Yep. So my screen is visible, right?
Yes.
Yep. So let's take this forward. So talking about first is MuleSoft ETL pattern. So talking about ETL, what ETL is. So ETL stands for extract, transform, and load pattern. So it's a very common process of extracting data from various data sources, applying transformations, and then loading that process data into the destination system like database or data warehouse. So MuleSoft provides efficient way to automate ETL processes by connecting multiple data sources, transforming data with its data weave language, and then loading into the target systems. So there are multiple approaches to achieve this integration, but when dealing with large data sets, one of the key concern for our architects, designers, and developers is the risk of fetching an overwhelming number of records in a single load session. So this can have the impact on performance, second memory usage, and system stability. So this is our major agenda and the challenge statement for today's meetup, that we're gonna look for the solutions for handling the large data sets while having the data transformations. So let's cover up the data handling scenarios first. So talking about the very first scenario we have. So loading an entire data set into memory. So this is a common practice while dealing with small to moderately sized data sets that can efficiently fit in the memory. So this doesn't cause any memory constraints, and this can be achieved without pagination and streaming architectural approaches. And now then comes up the second scenario, which involves exchange of huge data sets more frequently. So loading an excessive amount of data in the memory can cause excessive memory issues, and if the data exceeds the JVM heap limit, it can lead to performance degradation, out of memory errors, and even the application crashes. So to overcome these, we may look for solutions involving pagination, looping mechanisms, and streaming. So let's just dive into pagination and looping first. So yeah, so the very first is pagination. So let's explain this technical term in layman language. So it's a very common example, but say suppose we search for a phrase on Google and it displays some million of results in seconds, but it doesn't show them in one go. Uh, Instead, it splits the results into pages, say 0 to 10 records on the page first, 10 to 20 records on the page second, and so on. So this is what pagination is. And if we talk about pagination, taking an example of source as a database, so we split the records fetched from the database into pages uh, that to accommodate into memory. And while talking about pagination in database, we often come across two terms, that are offset and limit. So what are these? So while talking about offset based pagination, so offset stands for the record from which the retrieval is to be started, and limit is the number of records which are to be retrieved in one time. So these are basically particular to the MySQL database. And if I talk about Oracle, so we have offset and fetch next. Also, we have cursor based pagination, so where we get the next cursor to retrieve the next set of records, which I'll basically have a live demonstration for the cursor based pagination. So if I talked about pagination, so to iterate over the each page, we have looping mechanisms. So looping. So in MuleSoft, both pagination and looping are concepts for managing data retrieval and processing. So if on one hand, pagination is a technique to divide large data sets in small manageable chunks, looping mechanisms are used to iterate over them. So looping in MuleSoft can be achieved via splitters, by loops, which allows us to iterate over the collections or to repeat the execution of process. So, but one thing I'll say, while implementing the loops, it's very necessary to manage resources effectively, as we may tend towards performance issues. And the reason why I'm saying that is because of the recursive loops or the self-recursive loops that will basically lock up the resources and end up giving us the errors. So let's just dig deeper into the recursive loop situations and see some reliable solutions to get rid of such situations. So let's have some considerations towards it. So I say if you are working in Mule, you might have encountered too many nested context error, which is a Mule critical error basically. And so this error is typically created by a recursive call that exceeds the system predefined stack depth. And Mule 4 has built-in limitation to prevent a stack overflow when recursive calls are used. So the platform is basically designed to ensure that system doesn't run into memory issues or crashes due to excessive recursive calls. We can enforce a maximum depth for the nested child context, but obviously that's not ideal to increase the maximum depth to have more like to have more nesting and to have the more nested child context. So talking about pagination, so I say it's like a recursion but with modified parameters. So however, recursion have some disadvantages too. So if it exceeds a certain limit in Mule, you might get into the stack issues that we are discussing. So if you know there are definite number of pages which you are dealing with, you can come handy. So recursion can come handy in that place. And it can also help us in building the loop scenarios. But if I say, let's take an example of a recursive loop. uh, say I'll use a flow reference to recursively call a flow, for example, the REST API call. And then I can use a choice router to check the condition and exit once all the records are done. So that approach could lead to an issue which is mule critical, and it's similar to stack overflow issue. So recursively calling a flow causes deep nesting, and Mule throws this critical error. So as I have also depicted the error representation here, that is Mule critical and says too many child context nested. So talking about the reliable and scalable way to replace the recursive calls is a queue based approach. So queues. So queues are designed to handle large volumes of messages or tasks more manageably and linearly, so which can prevent the stack overflows, keeping your system stable. And talking about queues, we can consider the technologies like VM queues, anypoint M queues, and making them persistent and transient as per our use case and as per our choice. Right. So let's move ahead with a quick live demo for the same. Let me just pull up my studio. Mm, My screen is visible.
Your
Yes, yes.
yes, your screen is visible, but we can see that Google screen only.
Okay, let me reshare them. Mhm.
Yes.
Yes, so now it's visible, right?
Yes, your studio is visible now.
So I have started the deployment. So meanwhile, we can discuss the use case. So here I have taken the source as the Salesforce and then the target as a database, which is my SQL, right? So talking about the Salesforce bulk APIs, if I say it gives us the results on it doesn't give us the paginated results if we want to have the deal with the large data sets. So we need to paginate over them. So what I have done is I have taken the Salesforce REST API calls to fetch the locator, which will be our cursor to paginate over the next set of records. And I have used that locator to publish inside the queue, and then as soon as the locator is published to the queue, we'll listen that and then we'll make the next set of calls as per our number of records fetched, right? So if at very first I'll show you, so I just have a demo database as account. So basically I'm iterating over the account object, and then if I show you my table, so currently we doesn't have any records inside this. So let's loop over this and see if we end up having the records inside this. So let me just hit the request to the very first flow. Yep. So let's just debug it one by one. So I am just creating a bulk job here, then checking for the job status, whether it's completed or not. It's completed, storing that job ID, requesting for the token because we need that for the Salesforce API calls, then making the Salesforce REST API call, then fetching that locator. So one thing to note here is the locator is provided inside the attributes.headers named as sforce locator. So we are storing that locator here, and then we are also storing the first set of records that are retrieved from this very call. And then I'm inserting that first and then publishing that locator to the queue. So yeah, as soon as the record is published to the queue, so we'll have the ID, basically the job ID, because once we publish the message to the queue, if I only publish the locator, we'll not end up having the job IDs and the token that are required for the next calls that we need to have to fetch the next records from the Salesforce. So I am basically storing locator ID and also the token in the queue. So while publishing that and when it listens, we have the different variables set in here, which is the ID, token, and then we have the locator as well, right? And then we'll check for the condition if the locator that is fetched is not null or it has some value. So if it has some values, so it states that it has some records left to fetch, right? So we'll loop over this. We'll fetch the next set of records. We'll fetch the next cursor, we'll store that, we'll insert that set of records and publish the locator again inside the queue. So this will continue till the time we receive no records from the Salesforce and we have nothing as a cursor to fetch the records, right? So I'll just resume that flow here. And yeah, you can see the flow has ended. So let's just move over to the database and see if our records are inserted or not. Yep. So as you can see, the records are inserted into this. So we have successfully uh, inserted the records into the database from the Salesforce, taking as the source as the Salesforce. So this solution discussed seems like works perfectly fine. Um, Sorry. Yep. So this solution discussed seems perfectly fine, working perfectly fine for most of the scenarios that requires consuming paginated data sets. But as the saying goes, no solution is ever perfect, neither is this approach. So in some scenarios, if I talk about the structured and unstructured data, so handling structured data with pagination can be done anyhow, but handling unstructured data seems not handling unstructured data seems not efficient. So therefore we came up with the streaming to solve the problem of processing large data sets to avoid this issue, and also the issue of concurrent requests that end up with the memory exception, right? So I'll give over this to Sonakshi to explain you and take from forward from here for the streaming and types of streaming in Mule. So over to you, Sonakshi.
Thanks, Pragati. Let me just.
Yeah, everyone, like if by that time anyone has any question, feel free to ask. So we are moving to the next step. So by that time, if anyone has any question, you can drop it over the chat box or you can unmute yourself and ask.
Okay, so yeah, thank you, Pragati, for such a great explanation for pagination and looping. So now we are going to look into the concept of streaming and the types of streaming in Mule 4. So before diving deep into the types of streaming, we need to understand the concept of streaming, right? So streaming is a mechanism that basically processes large amounts of data efficiently by handling it in chunks rather than loading everything into the memory all at once. So what we are doing is that we are breaking down the data that is present in our source and handling it in the form of chunks. So what this helps in is that it not only helps in preventing the memory overflow issues, but it also improves the performance and the scalability of our applications. Some of the benefits, as I mentioned, are mentioned on the slide as well, that this kind of concept, the concept of streaming, is very memory efficient, as we are processing the large data without storing everything into the memory but just a chunk of data. And then we have the faster processing, because we are working on chunks, so it is reducing the waiting time or the time that could be taken for storing that into the memory. Then we have the scalability, since it's handling large files, API responses, and database queries without any performance issues, so it's a very scalable option. And the next is the optimized network usage. So how do streaming works? So as you can see in the diagram over here, in streaming we have a pointer that is also known as the cursor. So what this cursor is doing is it is pointing towards an instant of data at a point, at a particular instance of time from the source. It uses that data, tracks it, and accesses it from the uh, source of data, processes it over the fly, and then sends it over to the destination. Now, in this scenario, what is happening is that only that particular chunk of data is getting stored in the heap memory. Other than that, it is process it, then erase it from the memory, send it over to the destination, then point at another instance of data, process it, erase it from the memory, and then send it over to the destination. So the cursor in this case is encapsulated within a stream object, which can further be wrapped in multiple streams, which can further form a stream of chain known as stream chaining. With this approach, instead of loading the entire data set at once, data is getting read from the source, processed in smaller chunks on the fly, and ensures this concept basically ensures that the continuous flow of data is maintained and the memory overflow is reduced and improves the performance. So now we are going to look into the types of streaming in Mule 4. So there are three types of streaming strategies present in Mule 4. The first one is the non-repeatable stream. So the non-repeatable streams were also available in Mule 3. They were the default and the only muling strategy that was used, and that could be uh, that was uh, that could be used in Mule 3. The second kind of streaming strategy is that of repeatable in-memory stream, and the third one is that for file stored stream. Now, repeatable file stored stream is the default streaming strategy in Mule 4. So many of you might not be very aware of the fact that in the backend for your day-to-day connectors that you might be using in your integrations, whether it's a Salesforce connector or database or file, SFTP, listener, a request connector, or any another connector that is fetching the data, all these connectors in the backend are using the repeatable file stored streaming strategy. So yeah, next we are going to look into the concept of stream and iterable. So these are the two entities that we will be noticing while enabling the repeatable memory in the in-memory streaming strategy for various connectors. The concept of streams and iterables can be correlated to the concept of binary streaming and the object streaming. So as you can see over here, these are the file connectors, SFTP connectors. So one of the like common thing in all of these connectors is that we do not have any understanding of what kind of data structure we are going to get from these. So since we do not have any kind of understanding of the data structure, so how can we divide them into chunks? So in that case, we use stream, the entity stream. So in stream, these are whenever we are configuring the repeatable in memory stream into our connectors, these are the things that we have to look into, and there we are dividing it on the basis of the size. And when it comes to connectors like database and Salesforce, they do have the understanding of what kind of data is going to, the structure of the data that is going to be returned by these connectors. So in this scenario, we can divide them on the basis of their instance. For database, we have records. For Salesforce, we have objects. So in this scenario, we can divide it into the form of chunks. So in this case, the streaming strategy will be repeatable in memory, iterable. So now we are going to go ahead and start with the description of all the different types of streaming strategies present in Mule 4. The first one is that of a non-repeatable stream. So before going into the technicality of the concept, here is a small real life example for it. As you can see, for example, me and Pragati both are standing at two distinct points near the conveyor belt at an airport. We are both waiting for the same luggage to be picked up. Now, since I am standing near the luggage and I am able to access it, pick it up, then the same luggage will not be accessible for Pragati to pick up. So what is happening in this scenario is, since I was near, I get to pick the luggage first. So the same luggage was not there available for Pragati to pick up. So the concept of non-repeatable stream is a similar one. For non-repeatable streams, we cannot read the data or consume the data more than once. This means that once the data has been consumed by a component in the flow, it cannot be reread or accessed again. Additionally, they do not support simultaneous access by multiple threads in the flow. So as you can see in the diagram, what is happening is that the stream is pointing towards the data at the particular instance of time. It is processing it over the fly and then sending it over to the transform message for the transformation or the consumption. Now, once it has consumed it, if there is any another component present after that, it will not be able to consume it. In non-repeatable streams, yeah, so we have the key characteristics for the non-repeatable streams. So non-repeatable streams are optimized for performance, memory efficiency, and scalability. So as I've already told you, in non-repeatable stream, we are not at all storing the data at any instance in the memory. So in that case, there are no additional memory buffers or disk-based IO input-output operations that can be performed. Also, this is the best suited for processing large data sets or continuous data streams that do not require a lot of processing to be done or transformations to be done before sending them over to their destination. A few things that need to be considered while working with non-repeatable streams is that while they are highly efficient, they require careful handling to avoid issues when data needs to be referenced multiple times within a flow. Proper strategies need to be implemented to ensure that the data is persistent if we try to access them multiple times. So yeah, here we can see that a snippet for what I already mentioned earlier, that once the data has been consumed, once the stream has been consumed by the first component, the second component cannot consume it. So in this case, we are doing the transformation without using the concept of data weave streaming. This will be further explained in the session, but if we are not using data weave streaming to process the data or transform the data, then the right connector will not be able to consume the stream. A similar kind of situation will happen if we try to access the stream simultaneously, parallelly by two components in order to create or insert a data. So this is not something that can happen or that cannot be done in a non-repeatable stream. So the next concept is that of a repeatable in-memory stream. So as mentioned earlier, in non-repeatable streams, we cannot store data into the memory. So in order to make it and cannot consume it by multiple components in the flow. So in order to uh, tackle this situation, repeatable in-memory streams came into picture. So as you can see in here, the same situation is happening. The stream is picking up the data pointed at an instance, and rather than sending it over directly without storing it, it is storing it into a in-memory buffer. So in repeatable memory streams, the data is stored in the heap memory instead of the disk storage as buffer. This strategy starts with a 512 KB buffer, and if the data is larger than that, then the buffer grows till the increments are reached to the maximum limit that is set in the configuration. If the data exceeds the limit, it will cause an out of memory exception. So here we have the configurations. So in here, we are going to be setting up, these are the default configurations. So when we are trying to access from the by using the concept of stream, in that case we have the initial buffer size of 512, meaning we have an 512 in memory present to store the data. Then we have the increment. So if the data that is coming from the component is larger than that, so it is going to increment the buffer size by 512 kbs. Then if the maximum buffer size is reached, we are mentioning it over here. So if it is reached, then it is going to throw a out of memory exception. And the buffer unit over here is what we mention whenever we are trying to by default it is kb. We can like configure it on the basis of our requirement. We can configure it to g or mb that is present over the drop down. And the similar kind of situation is going to take place for the iterables as well, where we mention the initial buffer size for the amount of records that need to be stored first, then the buffer increment size, and then the max in memory instances. Now, mentioned, as we saw in the repeatable in-memory stream, that once the buffer memory is exceeded, like it's the max memory is exceeded, it is going to error out. So how can we tackle that situation? So in that situation, repeatable file stored stream came into picture. So the concept is similar to that of in-memory buffer, but instead of that, but the only addition to that is that initially it is going to store the 512 KB of data in the in-memory buffer. But once if the stream is larger than that, then what is it going to do is it's not going to increment it and up until the maximum limit is reached. It is rather than going to create a temporary file in the disk memory and store the data over there. So now the two components present over here can access both of them from the temporary disk that we have created. So yeah, in reality, for 0.1 vCores of there is a 8 GB of memory available. So what MuleSoft provides to us is 512 MB as a heap memory. After that 512 MB is full, data will be stored in the disk storage using the cryoserialization, which is the remaining memory. And when we are using the file stored repeatable streaming strategy, we can customize the buffer size in the memory size to match with our requirement as per the use case. So we can configure this as a larger buffer size if you so as to avoid the number of times Mule needs to write the buffer on disk. This increases the performance, but it has a limitation that the number of concurrent requests are limited. So for your application and the process because it requires very much additional memory. And we can configure this in-memory size to a smaller buffer size if we want to decrease the memory load at the expense of the response time. Now we are going to go and look into the demonstration for the same. What we are going to look into is two types of scenarios. The first is the difference between repeatable and non-repeatable streaming, and another one will be the difference between the repeatable in-memory and file stored streaming. So I hope the studio screen is visible. Yeah.
Yeah.
So I've already deployed. Yeah. So I've already deployed the application. So this is the difference between this. In these two POCs, we are going to see the difference between the repeatable and non-repeatable streams. So the benefit of using non-repeatable streams. What is happening in this case is that we are reading a file that has which a large data set present in it, and we are trying to immediately after that consume the data and write it into another file by using both the uh, streaming strategies. In this one we are using the non-repeatable stream, and in this one we are using the repeatable file stored stream with the default in memory size and the buffer unit. So I'll also show you that this is the folder where the two files are going to get created. So once I start the scheduler, we are going to see, okay, let me just check it. Okay. I think the path name has some issues. Let me just copy the path again. So let's deploy it again. While it's deploying, let's see the other POC that we have. So one, we have the representation of all the streaming strategies. So in the first one, we are using the non-repeatable stream. So what is happening is that in Ecto, we are fetching the data from the object account from Salesforce. And the streaming strategy for this one is non-repeatable iterable. So here I'm logging the stream, and in this point at the variable component, we are consuming the stream. After this, we are logging the response, and after that, we are trying to consume the stream again by creating it into the payload and then logging the payload. So we'll be seeing that in non-repeatable stream, we are not going to have the log. We won't be able to consume the stream again for the second component. Then in the repeatable one, the same situation is happening, but in the query, we have the repeatable in-memory iterable, which has the initial buffer size as 100 and the default settings. But in the repeatable in-memory stream flow, what we are doing is that we have constricted the initial buffer size to just one record and the buffer increment as well to one record. So we are going to see that if the buffer size increases and the data returned is more, if the stream is larger than that, then what is going to happen? And in the last one, we have the repeatable file stored configuration as the streaming strategy. So let us see. Yeah, so now our flow has started. So we can see that the non-repeatable streaming file is now present in the folder, and it took 3 seconds for it to be created. And if we are doing the same thing, just using the repeatable streaming strategy, then see, we have it took 8 seconds for the file to get created. Now you might think that the seconds or the time is very less, so why does it matter? But in this scenario, we were just working with 5 million records. What if the files that we are working in our usual use cases or projects are like have a large quantity of data set? So in those scenarios, the difference could be huge. So this is one of the major differences while working with them, that is non-repeatable and repeatable. And now we can look into how it's going to work connector by connector. We'll just send the request. Yes, so at this point, we have the first logger print the start of flow message. This logger has printed the start of flow. Then the second logger was printing the payload that was fetched, which is the non-repeatable iterator in case of the non-repeatable stream. Now in this point, the variable was created and the data stream was consumed over there, as we can see. Now, what we can see over here is that in the payload, if we'll go into the consumer closed flag as true, meaning that the stream has been consumed. After this, if we try to consume it over here, it is not going to let that happen. So if we log it, we have logged the variable over here. So we can see in the log, we have the payload. But once we try to consume the payload, we can see that the payload is an empty array, meaning it was not able to consume. And when we are logging it, we can see that an empty array is printed in the log. If we see in the transfer message, a similar situation is over here. Now, if we look into it using the repeatable in-memory stream, sorry, I'm gonna just send in request. And yes, so we can see when the first logger was printed, yeah, so over here we can see that this logger has printed the non-indented payload. The entire payload is printed by this particular log. So in the case of non-repeatable, it was just a non-repeatable iterator, but in this we have the payload. Now in the variable, we can see that we have the data consumed by the variable. Now we are going to log the variable and we can see that it is in the indented format. But once if we try to consume it by the payload, so here we can see that in the payload as well, we were able to consume the data stream. And the same has been logged and the same can be seen on the postman as well. So that is one of the major differences for non-repeatable ones. Now in this case, we are going to see that I'll just add a breakpoint over here as well and then send in. Yeah, so here we are going to fetch the record, the data stream. And since I had set, so if I'll try to log it, it is going to error out and say that the buffer has exceeded its max. So since the data that the buffer and the buffer increment that I mentioned over here in the component was just one records, and the records returned by the query were larger than that, so the error has occurred. And we can just see the same error over here as well. Now in the case of repeatable file stored, this kind of error is not going to persist and we'll be able to fetch the records just like we did in the case of. So the major difference that takes place in the file stream and repeatable in-memory file stream is that if the memory exceeds, then it is going to store in the temporary file, but if the max buffer is increased, then it is going to just error out in the case of in-memory streams. So yes, that was it for the demo. And for the last slide that we have for this concept, we have the summary. So whatever we learned during the Mule streaming concept is that streaming is a mechanism that processes large amounts of data efficiently by handling it in chunks rather than loading everything into the memory all at once. Then we have the streaming strategies, the non-repeatable one, in which the data can only be read once. This is the default and only streaming strategy present in Mule 3, and this is the most optimized for low memory usage but needs careful handling. Then we have the repeatable in-memory streaming, where it stores the data in the heap memory, and fast but limited by heap size can cause an out-of-memory errors. And the repeatable file stored, where it initially begins with the 512 KB storage in the buffer in memory, in the heap memory, but after that, if that is exceeded, then it stores in the disk memory in the form of a temporary file. So now I am going to hand over the PPT to Pragati so that she can explain the concept, the final concept of our day for data wave streaming.
Thank you so much, Sonakshi. And one more thing, I see a lot of people asking many questions. Thank you so much to them because it makes the session more interactive. And I believe seeing all those questions, others are also getting the concept more clear. Yeah, Pragati, you can continue.
Thanks, Jyoti. Thanks, Sonakshi, for the very well explanation. So let me just pull up my screen. Mm, Yep. So, coming on to the concept of the data weave streaming, so going directly into it. So, first we'll know like data weave. So, data weave is a powerful transformation language in Mule 4. We all know we are all working in MuleSoft, and it supports variety of data formats such as JSON, XML, and CSV. So, with data weave, we can transform data from one format to another. We can apply transformations and many other things. So one of the key feature of DataWeave is its streaming capability. So DataWeave feature that allows us to process large amount of data without running out of memory is DataWeave streaming. So with DataWeave streaming, we can analyze enormous amount of data effectively and process it in chunks, which means that we do not need to load the entire data into memory. Instead, we can process the data as it arrives in smaller chunks. So as explained by Sonakshi in the non-repeatable streaming strategy, so the non-repeatable stream cannot be consumed more than once, but we can utilize data weave streaming to output the transform messages result, which can then use wherever. So in this case, we are obtaining the data as a non-repeatable stream from the source and using it in the transform message deferred mode and doing the transformation solely on that specific stream or the payload, and then sending it to the next subsequent processes we have inside the flow. And to talking about enabling the data weave streaming, so we need to have set in the streaming property to true. And what this will does is, so this will allows data weave to read the input data as a stream, and we also need to set the default property to true. So what this does is, this will enable the data weave to pass the streamed output directly to the next message processor without saving it to the disk. So by configuring these properties, data weave processes the data as it arrives, it improves the performance, and it also reduces the memory usage. So as we discussed, the how to enable streaming, so we need to set the streaming property. So for reading the source data as a stream, so here we need to specify the MIME type of the source data. So that can be CSV, application JSON, and application XML, right? And also we need to set in the key parameters that is streaming, and that can be set as true, right? And then comes the deferred writer property. So what does it does is, so it is for passing an output stream directly to the next message processor. So now comes a very important property, that is stream capable, right? So what is stream capable? So while talking about sending the output stream, so it's an important property, that is stream capable. So we can use stream capable validator in our data weave script to validate it against the criteria. So as we like we previously specified for our input stream. So to ensure that our data weave script implies with streaming requirements and the input data is streamable, we can use stream capable validator. And two important points that comes up using the stream capable is that the variable, or the, we can say, the payload or the stream is referenced only once, and we can't have the negative access or the negative index selector for that very particular payload, right? And if all the criteria are met, the selected data is said to be streamable. So the stream capable annotation requires the use of input directive in the data weave script that basically identifies our MIME type of the data source. For example, we set in the previous slide, as you can see, as the application, right? So it just shows how we can write it inside, how we can consume that stream inside our like transform messages with the data weave. So we need to set in the at stream capable property, then we can set in the input and the MIME type of that, and then we can also set in the output and the MIME type of the same, and also we need to set in the default property as true, right? And these are the 2 points that we discussed, that there should be no index selector, negative in excesses, and otherwise it will give us the error that payload is not stream capable. And then also we can only refer it once, otherwise it will throw us the error that payload is not stream capable, right? So moving on to the data formats that are permitted in data weave streaming. So these are JSON, XML, and CSV. So we need to define the MIME types for the three of them, and also we need to define the parameters stating streaming as true. And one more thing, in XML, we need to set in the class path, that is basically the collection path from the root element, right? And post these configurations, we need to set in the default property as true inside our data weave transformations. So yeah, let's just quickly have a quick demo for the data view streaming. So my studio screen is visible now, right?
Yes, Pragati.
Yeah, thanks, Jyoti. Yeah, so coming on to this, so this is basically the demo to show us, like, while we are not having the data view streaming set in, we are using the default streaming strategy that we have inside our connector configurations, that is repeatable file store stream. And inside this transform message, you can see I'm having the normal transformation that we are doing. And in the second flow, where I am actually doing the streaming with data view streaming, is um, I am, let me just show you it as type. Yep. So here I am setting in the MIME type. So I am basically consuming a CSV file, which is having like approximately some lakhs of records. And then I'm setting the MIME type of it. I'm setting the streaming property value. It's at true inside this while reading. And then inside the transform message, I am setting in all stream capable property. I am setting the default true property, right? And let's just see what the time difference we have while we are setting in the data weave streaming and we are not setting the data weave streaming. So let's just head the request to the first flow and check for the time. So it took 2 seconds to process. And if I head the request to the second flow, which is doing the data weave streaming, just a second. Just a second, I believe. Yep. Let me just check my file. I see I'm consuming these. Yep, sorry. Yeah, so if I'm using the data weave streaming, so you can basically, this is very small time difference between if you're not using the data weave streaming and we are using the data weave streaming. It's like 2 seconds of the gap, and might be it's not that much visible to you. But if we use the file having like many records here, I'm just processing some like 5 lakh records, I believe. And then if we just increase the size to some file size to some more memory size, so you'll be seeing the difference, like will be very visible to you, right? So this was the demo for the data view streaming. So yep. So let's just quickly summarize that we have covered so far in the data view streaming. So first of all, data view streaming in Mule 4 enables data as it arrives and avoiding the full memory load. And how to enable it, we discussed by setting the streaming property inside the connectors, and we writing the default property as true. We have discussed about the permitted MIME types, we can data formats we can handle inside the data weave streaming. And also let's just now talk about the unsupported operations in the data weave streaming. So sort, group by, distinct by, so these functions basically require the full loaded data into the memory before processing. So these can't be used while having the data view streaming, because obviously streaming concept is very well says that we doesn't load the whole data into the memory, but we process them on the fly. So having these functions, so this will not satisfy our streaming concept, so we can't use them inside the data view streaming. And the very key benefit of data view streaming is obviously it's efficient for handling the large data sets, and but it requires the selecting compatible operations and compatible data formats, right? So now the fun part of the meetup. So we'll have a trivia, a fun quiz. Over to you, Jyoti, to handle this.
Thank you so much. Thank you for this detailed explanation. I hope everybody enjoyed this session and definitely learned a lot. So, yes, the most exciting part, I believe we have some questions added. Meanwhile, we answer that question also. I have added a link for Kahoot. I would request everybody to join that link. I'll be sharing my screen and I hope my screen is visible. You have to uh, enter this code there, the link as well. And I'm waiting for all the players to join. And as we see that the theme matches the mode for today. So this is not testing your knowledge, but we will be testing your excitement for today's session with this. Great. I promise that I haven't joined by different name. I'll make the game fair. We are above time. We'll wrap it up quickly as possible. I hope everybody has joined now. I'll wait for 2 more minutes, 1 more minute actually, and I'll start. Kahoot. Perfect. We have 29 people here. Let me know if anybody is having any issues while joining Kahoot app. Perfect. So I'm starting the Kahoot now with a count of 1, 2, and 3. So let's start the quiz for Mule data handling. And here's your first question, which is to test your excitement for today's quiz. So we have great options, and be mindful in selecting your option. Perfect. That's the excitement I wanted. Thank you, everybody. And also, we have one winner already decided. So, yes. So, our first question for today, you'll get 30 seconds. How traditional data streams are consumed in Mule 3. and your option are listed below. Fastest finger will win. 14 people. Okay, 19 corrected it. Let's check out the scoreboard with this. And we have Priyanshu as leading. Let's check out the next question. Which type of streaming is the default type of streaming in Mule 4? To be honest, I don't know the answer, but after watching the complete session, I'll also know the answer now. Perfect. 15 people corrected it. Let's check out the scoreboards. And we have Emil leading the scoreboard. Let's check out the next question, which is what happens if you write a non-repeatable stream after converting it to JSON in a transform message component. This is the time to flex those brain muscles. Perfect. 20 corrected it. I believe all of us have watched the session. Priyanshi is leading now. That's great. After every question, we have a new leader on the board. So the next question, which of the following pagination technique is least idle? And clap for those who are lightning fast to answer. Perfect. 16 corrected it. That's great. Let's check out the scoreboard. And Priyanshi leading again. And we have 5 players have reached answer streak 4. That's great. We have a good listeners in our audience. So yeah, here's the next question. What happened in a repeatable in-memory stream if max buffer size is smaller than initial buffer size and buffer size increment? What's your guesses? I think perfect. 15 corrected it. Actually, 2 corrected it. I'm sorry. 2 corrected it. The deployment would fail. I think this was a tricky question. She leading again. That's great. Now I think this will be lightning round. We have last 2 questions pending. What should be done if our API does not support built-in pagination? 23 answers already done. 13 seconds. 10 seconds now. 8 seconds. And I see a mouse with bow and arrow. So 21 corrected it. Good questions. Okay, Priyanshi still at the top. And we have Ivan and Manjira in third and second respectively. So our second last question, what is the primary advantage of streaming in data view? That mouse at the back is most highlighted, I believe. So 21 corrected it. Good listeners. And Priyanshi still on the top. That's great, Priyanshi. And Manjira on second, Mule on third, Ivan on fourth, Emil on fifth. The last question for today's session: which data weave function ensure DW script complies with streaming requirements and input data is streamable? Split by function, read function, stream capable function, and flatten function. This was an easy question though. 25 people corrected it. So, how much did you enjoy this quiz? And how did you like the picture? Perfect. I cross my fingers to show the answer. But yes, we have good response. 79% told it. Very amazing. Thank you so much. Great. Now let's check out the questions, pending questions. Do we have any other question, or I'll request everybody to turn on their cameras. We'll just click a cute picture with smile. Or if anybody has questions, we can address those as well. Thank you, Michael. Hi, Ramesh. Hi, Rajesh. Hello, everybody.
Hello, everyone, for attending the session.
Happy faces.
Thanks everyone. It was really a great session. Thanks Prakriti Sonakshi.
Thanks,
Jyoti Tope.
Komal. Thanks, all.
Thank you, everyone.
Please turn on your cameras. I'll click a picture now. Okay. Yes. 1, 2, and 3. Thank you. Thank you, everybody.
Thanks, all.
Thank you, everyone. Have a great
Do share your
Valentine's Day.
feedback.
Yeah, thank you,
Yeah.
Thank you.
Sonakshi and Pragati.
Thank you,
Bye.
Very
everyone.
great
Thank
session.
you. Bye
Happy
bye.
Valentine's Day.
Bye.
Enjoy your day. Thank you, Priya, for helping me out
Yeah,
throughout.
thanks, Jyoti. It was a great work. And thanks to all the speakers. We hope to see you again here.
Yeah, definitely.
Yeah.
Okay.
Yeah,
Have a great
Jyoti.
evening.
Yeah. Thank you so much. Have a great weekend ahead. Bye bye.
You too. Bye.
Bye.
Bye,
Bye,
everybody.
Priya. Bye, everyone.